Okay, so for the Unit 1 review, the vocab I'm not going to go over. There's plenty of resources for y'all to look up these definitions. I do just want to go over the math. Okay, so we're looking at points, lines, and planes. Okay, so our first question is B, E, and G coplanar? Okay, now the definition of coplanar is that any three non-collinear points can make a plane. Okay, so this one's kind of tricky. So if I have B, E, and G, okay, they're non-collinear. So I can draw a diagonal plane through those points. So yes, they are coplanar. Okay, so part B, so are G and B collinear? Well, okay, again, the definition of collinear are any 2 points can make a line. Okay, so I can draw a diagonal line through B and G. So yes, those are also collinear. Okay, which planes intersect at the line EF? Okay, well, here's line EF. Okay, so this is this plane right here, so that's side plane. Okay, so I'm going to label that. I just need 3 of those points. So I'm going to say plane ABF. And, okay, the other one is this bottom plane, and I'm going to call that EFH. Okay, you could have labeled it differently than me, but as long as you're talking about those 2 planes, then we're good. Okay, so this question 2 is part more kind of vocab. Okay, so we have a line is the intersection of 2 planes. A point is the intersection of 2 lines. Okay, opposite rays always form a straight line. Okay, a pair of opposite rays. Oops. So Z is the common endpoint, so I have one going this way, and then one going that way. So this is Z, and we'll call this one T, and call this one X. Okay, so the way I label it is I do my endpoint first. So Z, T, and Z, X. All right, so for segment addition, okay, let's look at question 1. So we have M is the midpoint of AB. So here's the midpoint. This is A, this is B. So I know that AM is congruent to MB. Okay, AM is 4x plus 2. And then MB is 6x minus 10. All right, well, those are congruent. Okay, and if they're congruent, I just set them equal to each other. So I have 4x plus 2 equal to 6x minus 10. And then I'm going to solve. So I'm going to subtract 4x, add 10. So I get 12 is equal to 2x. So x is going to equal 6. Okay, but my question are, what are the lengths of AB and MB? So let's first solve for MB. So that's 6x minus 10. So that's 6 times 6 minus 10, which is 26. Okay, so that means from here to here is 26. So from A to M is also 26. So AB, the entire thing, is equal to 52. All right, so question 2. So if point B is between A and C, so it doesn't say it's the midpoint, it just says it's between. I'm going to go ahead and draw line AC. And B is somewhere in the middle. It doesn't say where, it doesn't say it's a midpoint. Okay, so I'm just going to draw it in. All right, so then I have AB is equal to 17x plus 12. And BC is equal to 3x minus 5. and AC is equal to 127. So that's that whole thing. So from A to C is equal to 127. Okay, and I want to find the value of X, segment AB and segment BC. All right, so to do that, I'm going to do part plus part equals the whole thing. So I have 17x plus 12 plus 3x minus 5 is equal to 127. So then I can combine like terms. So I get 20x plus 7 is equal to 127. So I get 20x is equal to 120. So x is equal to 6. Okay, but the question is, I also need to plug it in to solve for A, B, and BC. So I'm going to go ahead and plug that in. So I get AB is equal to 17 times 6 plus 12. And then BC is equal to 3 times 6 minus 5. So I'm going to go ahead and enter that into my calculator. So I get 17 times 6 plus 12, and that's 114. So that means BC is going to be 13. Okay, question 3. So I have RT bisects SP. So I know that P to C is equal to S to C because that is a segment bisector. Okay, we have CP. So from here to here is 5x plus 4. And then from S to P, so that whole length, so from here to here is 8x plus 68. So find CS. Okay, so the tricky thing about this is I don't know what C to S is. But since they're equal, that's also 5x plus 4. So I'm going to do 5x plus 4 plus 5x plus 4 and equal that to 8x plus 68. All right, so I'm going to combine my like terms. So I get 10x plus 8 is equal to 8x plus 68. So I get 2x is equal to 60. So x is equal to 30. So it wants me to find CS, so I just got to plug it in. So that's 5 times 30 plus 4. So that's 154. All right, question 4. So in the diagram, K is a midpoint of JL. So I know from J to K is equal to K to L. So JK is x squared, and KL is 5x plus 24. Okay, and I want to find the values of x. All right, well, since those are a midpoint, they're equal. Okay, now my issue is this one is that I see an x squared, and if I see an x squared like this, I need to think to myself, I need to factor. So in order to factor, I need to set things equal to 0. So I'm going to scoot everything over by subtracting it to the other side and set that equal to 0. So now I need two numbers that multiply to our C value, which is negative 24, but add to our B value, which is negative 5. Okay, so to do that, the two numbers that I think of are 8 and 3 because the difference is 5, but I need to think of which one needs to be negative. So if I have a negative 5, I want the 8 to be negative because negative 8 plus 3 gets me negative 5. Okay, so not only do I have to solve for those numbers, I have to write them as factors. All right, and then to solve, I set each value equal to 0. So these just turn into the opposite. So this is x is equal to a positive 8, x is equal to negative 3. And that gets me both values of x. Okay, question 5, so another segment addition. So we have B is the midpoint of AC. So I know A to B is equal from B to C. Okay. Then we have AC is equal to CD. So from here to here is equals from here to here. Okay, we have AB is equal to 3x plus 4. AC is equal to 11x minus 17. And CE is equal to 49. Okay, we want to find DE. So our goal is to find that little piece right there. So the first thing I know is I want to look at the segment AC. Okay, so this is like one of the ones that we did before. So I know from A to B is 3x plus 4. So from B to C is also 3x plus 4. And the whole thing is 11x minus 17. So I'm going to add those together and set it equal to 11x minus 17. So I get 6x plus 8 is equal to 11x minus 17. So I'm going to solve. So I get 5x is equal to 25. So x is equal to 5. Okay, so what I'm going to do is plug it into AC. So that's 11 times 5 minus 17. And I get 38. So from A to C is 38, which means from C to D is 38. So now I'm looking at segment CE. So CE is equal to 49. So to get this blue part of the segment, DE, I just got to do 49 minus 38. And I get 11. So DE is going to equal 11. All right, so part 4 is angles. Okay, so in the diagram, RT is perpendicular to SV. Okay, so I'm going to go ahead and draw that in. I'm going to say this is my right angle right here. Okay, so another name for angle 2. Okay, you could give me two names. You could say angle WSV. Or you could say angle VSW. Okay, name the sides of angle 3. Okay, well, one of the sides is ray SR. Make sure your endpoint is first. Okay, and our other side is from S to W. So always have your vertex come first when you name the sides of an angle. All right, so then we have the vertex of angle 1. Well, here's angle 1. Our vertex is point S. I'm just going to write S. Okay, then we have classify angle 2. Okay, classify means like what type. Is it acute, obtuse, right, or straight? So angle 2 is less than 90, so that's acute. And then we have if angle 2 is equal to 48, find the measure of angle 1. Okay, well, angle 2 is 48. This one is 90. I see I have a straight line. So if I were to add, I'm going to call angle 1 x for now. If I were to add 48 plus 90 plus x, that should equal 180. So then you just solve. So I have 48 plus 90, which is 138. And then you just end up subtracting 180 minus 38, which gets us 42 degrees. Okay, question 2. So this is our angle relationships. So name a pair of vertical angles. Okay, well, I can say angle RNM and the one directly across from it, ONQ. Okay, so a pair of adjacent angles, so they just have to have a common side. So if I pick angle RNM again, okay, I'm going to make sure I keep that common side, so I'm going to say MNP. All right, and y'all's answers can vary on this. I'm just giving y'all one example. Okay, a linear pair, so a straight line. Okay, so if I draw this straight line, I have angle RNM. and angle RNO. All right, so we got a little bit of angle addition. Okay, so if KM bisects JKL, so this is our angle bisector, which means that angle JKM is congruent to angle MKL. All right, angle JKL is 92. So that whole angle is 92 degrees. So I can actually figure out what each of those angles should equal. So each angle should equal 46 degrees. Okay, then we have the measure of MKL is 5x plus 1. Okay, so all I need to do is set 5x plus 1 equal to 46 and solve. So I get x is equal to 9. Okay, question 2. So MPR, so that whole angle is 44 degrees. MPN is 4x plus 5, so that's this guy right here. And then NPR is 2x minus 3. Find the measure of MPN. Okay, so if I add the red angle and the blue angle, it's going to equal 44 degrees. So I'm going to say 4x plus 5 plus 2x minus 3 is equal to 44. And yes, I know it's not drawn to scale, but that's okay. So I get 6x plus 2 is equal to 44. So I get 6x is equal to 42. So x is going to equal 7. I want to find the measure of MPN. So I'm going to plug that back in. So that's 4 times 7 plus 5. And I get 33. Okay, question 3. So OB bisects AOC. So same kind of thing. I know that AOB is equal to BOC. All right, AOB is 2x minus 3. And then AOC, so that whole thing is 6x minus 48. Okay, so and this is another one where you think, so if AOB is 2x minus 3, BOC is 2x minus 3, and you're going to add them together and set it equal to the entire angle, which is 6x minus 48. And then combine like terms, so I get 4x minus 6 is equal to 6x minus 48. So I get 2x is equal to 42. So x is going to equal 21. And again, it wants me to plug it back in. So I want to find BOC. So that's equal to 2x minus 3. So I'm going to do 2 times 21 minus 3. And I get 39. Okay, and then this last part is angle relationships. So for question 1, okay, we have angle DBA and angle CBE. Okay, and we want to solve for x. So in order to do these, you really need to first identify the angle type. So the angle type on this is vertical. What I know about vertical angles is that they're congruent. So I'm going to go ahead and set those equal to each other. And then solve. So I subtract 3x, I get 4x. Subtract 2, I get 34. Which on this one I get a decimal, which is 8.5, but that's fine. Okay, on number 2, so the angle 1 and angle 2 form a linear pair. So what I know about a linear pair is if I add them together, they equal 180. So angle 1 is 6x plus 11. Angle 2 is 10x minus 7. Okay, so in order to find angle 2, I really need to find x first. So I'm going to go ahead and combine my like terms. So I'm going to subtract 4 and then divide by 16. So I get x is equal to 11. And then I need to plug it back in for angle 2. So I get 10 times 11 minus 7. And I get 103 degrees. Okay, so question 3. So G and H are complementary. So what I know about G and H, if I add them together, they're going to equal 90. So angle G is 6x minus 15. Angle H is 3x plus 6, and that needs to equal 90. So I'm going to combine my like terms. I get 9x minus 9 is equal to 90. So add 9 and then divide by 9. So x is going to equal 11. And I want to find the angle H, so I'm going to plug that in. So I get 3 times 11 plus 6. So I get 39 degrees. Okay, question 4. So these sometimes are the trickier ones. So we have angle P is 5 less than 4 times the measure of angle Q. So reading that statement alone, okay, Q is my unknown. So I'm going to call angle Q X. Okay, so now if I read this statement again, okay, we have angle P is 5 less than 4 times X. So 4 times X and then 5 less than that can be written as 4X minus 5. Okay, P and Q, so once I have that, P and Q are supplementary, so that means if I add Q plus P, that's going to equal 180. So angle Q is X. Angle P is 4x minus 5. So I'm going to combine like terms. So I get 5x is equal to 185. So x is going to equal 37, but it wants me to find angle P, so I do need to plug that back in. So I get 4 times 37 minus 5. And I get 143. Okay, question 5. So 1 and 2 form a linear pair. So again, if I add angle 1 and angle 2, that is equal to 180. Okay, so then we have angle 1 is 18 degrees less than 5 times the measure of angle 2. So angle 2 is now my unknown. And I call that X. So we have angle 2 is now equal to X. Okay, so then I'm going to read that statement again. So angle 1 is 18 degrees less than 5 times X. So 18 degrees less than 5 times X is 5X minus 18. Okay, so it wants me to find angle 1. So I'm going to do 5X minus 18 plus X is equal to 180. So I get 6X minus 18 is equal to 180. So I get 6X is equal to 198. So X is going to equal 33. Okay, he wants me to find angle 1, so I need to plug it back in. So that's 5 times 33 minus 18. And I get 147. Okay, and this last one, it didn't have a picture, but these were supposed to be, and that's my bad, y'all. Sorry about that. So this is going to be angle 1 and then angle 2. Okay, so if those are vertical angles, which they are going to be congruent. So I'm going to set angle 1 congruent to angle 2. So angle 1 is 2x squared, and angle 2 is x squared plus 11x minus 30. Okay, so what I need to do is I need to get everything to one side because I see that x squared. So I'm going to subtract. Okay, so I now have x squared is equal to 11x minus 30. And this is like something that we've seen before. I need to get everything to the left. So that becomes x squared minus 11x plus 30. And then I'm all set to factor. So I need two numbers that multiply to be our C value of 30, but add to be negative 11. Okay, and so right away the numbers that come to mind are 5 and 6, because if I add them, they become 11, but my issue is I need a negative 11, so these actually need to be negative. So this becomes, this becomes x minus 5, x minus 6, and then to solve for both x values, I set them both equal to 0. So I get x is equal to a positive 5, x is equal to positive 6. Okay, so it wants me to find angle 1. Just find x on this one, that's fine. That's all you need to do on that one, okay?